So now come to the effects of conjugation and resonance as bond length, stability, acidic strength, basic strength, and much more. So one by one I am going to take the topics and depict you with the help of examples the bond length, the stability, and the acidic or basic strength. So first, bond length. That means how the resonance or conjugation affects the bond length within the conjugated system. So you know, because of the conjugation, the delocalization of the pi electrons takes place within the conjugated system, and because of the delocalization of the pi electrons, somewhat double bond character takes place between the conjugated atoms, right? So you know the bond length of single bond is more than the bond length of the double bond. That means the bond length between the conjugated atoms decreases because it has somewhat double bond character because of the conjugated system, right? So let me write first, and with the help of suitable examples I am going to show you. Due to conjugation, resonance takes place. That is delocalization of pi electrons within the conjugated system. Takes place, and due to this, somewhat double bond character, come in existence between the conjugated atoms. Thus, the bond length between the conjugated atoms decreases. Right? Because as you know, carbon, single bond carbon, the bond length is 154 picometer. Right? Now the double bond length is 133 picometer. So in somewhat double bond character is there because of the conjugation. Somewhat double bond character present. Sometimes it is single bond, sometimes it is double bond, and it is shown by the dotted pi bonds, right? So here it must be more than double bond and less than the single bond length. That means it must be in between the 154 to 133 pm. Right? So the bond length between these two carbon attached must be in between this. Right? So it is clear that because of the conjugation, when the pi electrons delocalization takes place and somewhat double bond character come in existence between the conjugated system, then the bond length decreases. For example, CH2 double bond CH, single bond C H2 and a positive charge is here. And here the pi electrons are there, single bond, this means sigma bond, and here is the positive charge. So conjugation is there, the delocalization of these pi electrons takes place with the positive charge, and here positive charge means empty orbital, and these move. And the next resonating structure will be CH2, CH, double bond CH2, and this time positive charge comes on this carbon. Again, these pi electron shifting takes place, and the first species comes in existence. So here you may clearly observe that if you are going to make the resonance hybrid of these two structures, these two are resonating structures. These two are resonating structures, and the resonance hybrid is CH2, CH, CH2, and somewhat double bond character throughout the conjugated atoms, right? And this is the resonance hybrid. So here the bond length, this and this also, both the bond length is in between, less than double bond and more than the single bond. So take one more example. Double bond, single bond, and here is a double bond, right? In this question, the conjugation is present. These pi electrons shifting takes place, and the next resonating structure will be double bond this time between this, and here comes the positive charge, and here comes the negative charge, right? Again, the shifting takes place, and this is coming in existence. These are two resonating structures. These are resonating structures, right? These two are resonating structures. Now the resonance hybrid. Resonance hybrid is dash somewhat double bond character throughout the conjugated atoms come in existence. So here this is the resonance hybrid. So here you may clearly observe that this bond length between the conjugated atoms has more than the double bond, and it is less than the single normal bond, right? So here somewhat double bond character, somewhat double bond character. So bond length decreases. Bond length decreases, right? So bond length decreases. So you come to know from this phenomena that because of the conjugation present in the conjugated system, the atom attached, the conjugated atoms attached, the bond length between them becomes less, decreases than the normal single carbon-carbon bond, because the somewhat double bond character taking place between the conjugated atoms, right? So bond length decreases due to the resonance. Now come to take an example. So the question related to the bond length is here. Then between cyclohexane and benzene, which has shorter bond length. So the cyclohexane is this, and the benzene is this. So here you may observe that in cyclohexane neither kind of conjugation present. Here between each carbon-carbon atom, here is the pure single bond. That means the bond length will be 154 picometer. And here in benzene, the pi electrons are in conjugation. Pi electron, sigma bond, pi electron, sigma bond, pi electron, sigma bond. So conjugation is present. So delocalization of pi electrons takes place. So because of the delocalization of pi electrons, the second resonating structure comes in existence. That is this, and now again the shifting takes place because the conjugation present, and the resonance hybrid of these two. Resonance hybrid. These are the resonating structures. These two are resonating structures. The resonance hybrid will be this. This is shown as somewhat double bond character taking place. The pi electrons movement takes place, circulation, right? So it is not purely double bond. It is not purely single bond. It is sometimes it is double, sometimes it is single bond. So somewhat double bond character present. So here the bond length between each carbon atom in the conjugated system is less than the single bond and more than the double bond, because it is not purely the double bond, right? It is not purely the single bond, not purely the double bond, it is in between. So this bond length is having less bond length than purely carbon-carbon single bond, right? So cyclohexane and having more bond length than the benzene, right? Clear? Now come to the stability of the molecule, the effect of resonance and conjugation on the molecule stability.